Problem 35. In this problem, I'm asked to evaluate this following integral. So here I will apply U-substitution. So in U-substitution, I know that I need to express everything in terms of U. So what I will begin by doing is I will say, let U be equals to something. But now I need to first find or look at my integral or my integration. So I'm told that I'm supposed to integrate 3x root 1 minus 2x squared dx. So here, what I've learned from someone is that to do this, I need to look for the u expression, not u expression, man, but the integrand, the longer u integrand, or one that's in a fraction or one that's under something, and then in this case it is the root. So I will make my u, I will say u is equals to 1 minus 2x squared. So here I'm not going to add the root as yet because then I will apply it later on. So what I want to do next is I want to find my the derivative of u in terms of x. So I will say du all over dx is equals to 1 minus 2x squared. So here, because I am applying the rules of derivatives, I will find the derivative of 1 minus 2x squared. So this then becomes, so I apply the power rule of differentiation, which is n multiplied by x n minus 1. So what this simply means is that I bring down the power and I subtract a 1. So in this case, it becomes du all over dx is equals to the derivative of a constant is 0, so that goes away. So now what I'm left is the second part of this expression. So I write my negative sign and then I write the coefficient, which is 2. I open my brackets. So here I'm going to differentiate x squared. So I bring down the power, which is 2. I put back my x. So it's 2, the exponent is 2 minus 1, so which is 1. So now it becomes 2x. So this then continues to become du all over dx is equals to negative 4x. So now what I want to do is I want to separate the du and the dx. So I'm going to rewrite this by cross multiplication. So this then becomes du is equals to negative 4x dx. So now I have my du separate from the x dx. So then I will remove the negative 4. So divide by negative 4. I know that I have a coefficient of 1 here, so this becomes 1 all over negative 4. So this then becomes negative 1 all over 4 du is equals to x dx. So now I have separated my du and the x dx. So now it's easier to then work with. So what I want to do next is then rewrite my equation, my integrands here. So this becomes the integrand of, I then rewrite my 3. I'm going to put back the root because I haven't used it yet, and then I put back my u. Remember that my u is 1 minus 2x squared. So this is the same as if I'm saying u. If I substituted this back here, it is the same thing. So now, in the derivative that I found here, I said that x dx is equals to negative 1 all over 4 du. If we look at this expression, we can see that there was an x here, and then there is a dx here. So if I wrote it as x dx, it is the same because x dx, I already know that it's negative 1 all over 4 du. So which means I can say it's the integrand of, the integral of 3 root u, and then x dx, I can just simply substitute by negative 1 all over 4, and then I write my du because I've already identified that x dx is the same as negative 1 all over 4 du. So after this, I can then move this constant outside the integration sign. So this becomes negative 1 all over 4, open integrand, then it's, integration sign, 3 root u du. Okay, so now this tells me that I need to evaluate what's inside here. So I won't deal with the 3, but I will just be evaluating this part of the integrand here. So what I want to do here is apply the power rule for integration, which says x exponent n, then instead of negative, I write a plus sign, all over n plus 1. This n here simply means some variable that I have. Some variable that I have here. So to evaluate this, just to move this, then to evaluate what I have here, I will then have the root of u. I need to evaluate it by applying the power rule for integration. So first what I want to do is I want to rewrite this so that it's easier to work with. So I've got u exponent 1 all over 2. So according to this power rule of integration, it means it is going to be u exponent 1 over 2 plus 1 all over 1 all over 2 plus 1. Let me remove this. So I'm going to apply the rules for exponent in order to add this. So 1 all over 2 plus 1 is the same as 1 all over 2 plus 2 all over 2. So because the denominators are the same, I add the numerator. So this is equals to, so in the bottom is 2, so it's 1 plus 2, then this becomes 3. So this equation then becomes u 3 all over 2 all over 3 all over 2 because I've already determined this. But I can further simplify this equation because I know that this can also be rewritten as 3 all over 2 divided by 3 all over 2. It is the same thing. So I can change this division sign to multiplication. So this then becomes u 3 all over 2 multiplied by 2 over 3. When I change the sign, then I flip this. The denominator becomes a numerator and the numerator becomes a denominator. So this becomes 2 all over 3 u 3 all over 2. So now I have got this whole mess here of an equation that I have now determined, which now becomes what I've evaluated of the u. So now it means I can substitute it back to my original equation to then find out or to further work with it. Sorry, just remove this. So I've already determined that my u is now 2 over 3 u exponent 3 over 2. So I continue and say, since I've already evaluated this, it means that this integration sign will go away. This is just the rules that I've learned and encountered. Please note that I'm taking calculus for the first time, so some of these things, I don't have the rules as yet, but I'm learning with you as we go along. So this is also the purpose of these videos. So this becomes negative 1 all over 4 if I remove this and remove this, because because I have evaluated this and that goes away. So this then becomes 3 multiplied by 2 over 3 u 3 all over 2 close brackets. Okay, so this is then equals to negative 1 all over 4 multiplied by 3. This becomes negative 3 all over 4 multiplied by 2 all over 3 u 3 exponent 3 over 2. So now I can further evaluate this 3 and this 3 cancels. So this becomes 1, this becomes 1. 2 divided by 4 is the same as negative 1 all over 2 u 3 all over 2. So because I have further simplified this, it's now easier to work with. So I have negative 1 all over 2 u exponent 3 all over 2. Because I have this and I've already determined what my u expression is, in this case it's 1 minus 2x squared. It means I can substitute my u expression into this equation. So what I have here is negative 1 all over 2. I substitute with my u, which is 1 minus 2x squared exponent 3 all over 2. This is then my final answer, but I also add some c, which is a constant of integration. Constant of, this is the integration sign. So this becomes my answer for problem 35.